Hello, hello, hello. So today's going to be a messy lesson, and I've got this shirt on. Everybody's always going, "Hey, nice T-shirt you have, nice hat." Well, there. So that's out of the way. Today we're going to talk about physical and chemical changes. So it's going to be messy. That's why I'm outside. And when you do these experiments, I'm going to show you what you need, and you can also look it up on the internet. Do it probably outside because it's messy. So first of all, physical changes. Physical changes is when there is no change in the chemistry makeup of something. For example, water is H2O, dihydrogen monoxide. Okay, there's your word to say today. Dihydrogen monoxide. Start calling water dihydrogen monoxide from here on in. Just go, "Oh, I'm thirsty. I'd like to have some dihydrogen monoxide." So water comes in various states. Solid, liquids, and gases. Okay, so here it is, solid. This is still H2O. Okay, here it is, liquid. This is still H2O, right? Sorry, Rocky. So it's still a liquid. As I exhale, if I went up to a mirror and I breathed on a mirror, you would see that liquid would start to form there because I'm exhaling H2O, dihydrogen monoxide, as a gas. So this piece of paper, this is paper. This is still paper. This is still paper. It's a physical change. I'm tearing it up. I'm making it into smaller amounts. There you go. If I take sugar and put it into water, it's still sugar in there. It breaks down into little ions and so, but you can still get the sugar back. We call that reversible. Now, this was the paper because I'm not going to waste anything. This was the paper that we did our secret messages on. Now, yesterday, when I was trying to show you how to get that secret message out of there and heating it up, as I was heating it up, I almost started it on fire. Now, if I start something on fire, that's no longer paper. I'm giving you right now carbon dioxide and heat and light, and it hits. See, look at that. That's why we have a fire ban going on. So this is a chemical change. I've changed this paper into carbon dioxide and water, and I got that soot and the smoke coming all around. This is a chemical change. When you have a chemical change, you actually change what the material is into something else. You still have the same atoms. You still have carbon, hydrogen, oxygen, whatever. This one stays the same. Look at this. We've already got a mess blowing around in here. Now, there's a lot of different chemical changes, and there's 4 things you look for in a chemical change. One is a precipitate forming, but I don't have the chemicals to do that. We used to put 2 clear colorless liquids together and it turned yellow, and after it settled there was a yellow solid and then a clear colorless liquid, which were 2 different substances. A precipitate is a solid that forms out of 2 gases or 2 liquids going together. I haven't really got an example of that for you. Another thing that you probably look for was heat and light given off. I just gave you that example. When you burn something, you give off heat and light. Yeah. Now, a gas given off, usually you see something bubbling. So we'll show you some examples of that. And a change of color. So if I add 2 things together and I got a change of color, most likely I have a chemical reaction. Not all the time, because we did the purple cabbage and we could change from one color back and forth, and changing it back and forth, it was just a precipitate. I mean, sorry, no, it wasn't a precipitate. Sorry, Rocky was just stepping on something and knocking everything over. So okay, that's kind of thing. So you have lots of different examples. You have rotting. When something rots, it's a chemical change, and it's giving off those smells. So you've got rotting is decomposition. I have vinegar in front of me. Okay, vinegar, of course, you're gonna know, you got lots of vinegar around the house. Vinegar, you can even do one with an eggshell. Take an eggshell after cooking up some bacon and eggs, and you can put it in there and it'll start to bubble. If it bubbles, it's giving off of a gas, and it's changing. A lot of times that gas could be carbon dioxide. And you can test that out by catching it, like in a balloon or something, and pouring it onto a flame, and the flame goes off. Flames don't burn in carbon dioxide, that's why. So I could drop that in there, but it slowly bubbles. You could actually take a full egg and put it in there and get rid of the whole shell, and have the egg without a shell on it, a little creepy little thing. But of course, as you all know, you want this one. Baking soda and vinegar. What's going to happen? Well, I'm going to put them together, and there's going to be a reaction. Sodium bicarbonate is going to change when it goes to acetic acid, which is good old vinegar. And I got a gas giving off. And I'm making carbon dioxide. And it's going all over the place. Because that's why we're doing this outside. It's going to be a messy day. My favorite one that I really haven't tried, but I know it's going to be fun. I'm going to move all this stuff aside. I'm bringing in the heavy guns in here. We are going to make elephant toothpaste. Now, it took me, Carrie Bowie went and delivered some of this because I'm not going to stores, I'm isolating. And she had some, and there's hardly any to be found. This is like gold. This was, first it was toilet paper, now it's yeast. I need yeast, and I need hydrogen peroxide. Hydrogen peroxide is actually dihydrogen dioxide. Remember, water was what? Say it. H2, dihydrogen monoxide. This is H2O2. And you know what? This O2 really doesn't really like to stay there. It likes to go. Sunlight destroys it. So notice this container no sunlight can get in here. No sunlight's coming into this thing. So what we're gonna need is some dish soap, some dihydrogen monoxide, dihydrogen dioxide or hydrogen peroxide, yeast, and some warm water. And to make it look better, I'm gonna put some color into it. So what they say is you need half a cup. Now, this is old. I found out the death date on this one was, I think, 2009. So hopefully it'll work. If it doesn't, go on the internet. There's tons of them. People that have big buckets full and start moving. And as the wind's blowing everything around here. Okay, so it says, get a half a cup. Okay, I got half a cup. Half a cup of it there. Now, what I got to do to it is I'm going to mix a little bit of this to it. Now, you can use it without it, but this is just going to make the bubbles better. Okay, so put exactly, measure really carefully, some dish soap in there. Yeah. Now, I'm going to need 1 tablespoon of yeast. Yeah, really have to measure that exactly. Yeah. And 3 tablespoons of warm water. Now, we did this experiment in high school biology, is where we took beef liver and put it into hydrogen peroxide, and it bubbles. Because beef liver has an enzyme in it that's called catalase that causes this stuff to break down. And so you could throw beef liver in there, but it won't be as fast as this. Yeast also has catalyst. Yeast is actually a living organism. So I've got some warm water here, and I mix it all up. Now, while that's mixing up, why don't I make the toothpaste colorful? Now, I could put 1 color in there, but I'm thinking I might dribble down the sides of it. All the colors. So I'll take some green, and I'll put the green down this side. I'll try. I don't know if this will work. There's the green. And put some red down this side. And some blue. Because it's starting to all mix in there. Now, what I got to do is mix it together. We'll see what happens here, folks. So, Make sure you got lots of visual on it. You can see there's so many people writing. I can't tell if it's visual. Okay. Let's put the catalyst of yeast into here. Elephant toothpaste. Yum, yum, yum. Let's see what happens. Well, slowly coming up. Slowly coming up. It's rising. It's rising. Now what would happen if I put it into a narrower container? Such as if I put it in a narrow pop bottle and had all that. Because as you see, this is coming to the top. I'm making some toothpaste. Probably this needed to be, you know, a little bit newer. But here, look at this. I got some toothpaste coming out here. I've got a chemical reaction. How do I know it's a chemical reaction? I have gas formed. See, take a look. There's a gas formed. And I got a nice little bubble here. And it's making oxygen. Because actually what it's doing is H2O2 is decomposing, breaking down to water and oxygen. So look at this. This is the elephant toothpaste. Usually it goes faster. Usually it goes real fast and it flies right up. And away it goes. Oh, look how colorful it is. Hey, let's add some more color to my, drop that in there. Yep. Yum, yum. So, there. Now, don't get any of this on you. It's only 3%. But don't get any of that on you. Try it. Maybe try some different variables. This is warmer. If there's a narrower tube, that's the way I think I'm going to do it next time, is a narrower tube. Look at this. And don't eat this. It's toothpaste. Don't brush your teeth with it. Okay? So we'll talk to you some other time. Bye-bye.